Yeah, but I think you mentioned some opening there as well. You just moved something to production, right?
Yeah. So yesterday we went live with we usually try to go every third week or something like that, once a month, depending on how much work we actually produce. But now we had probably worked for like 3 months, which is so bad with all this modern software engineering experience you have. You shouldn't. You should go to production often and small. Don't
focus on the bad.
Focus on the positive. But now it was a big.
We had and finally we went to production.
But it is actually, and it went live, and it was kind of smooth to go live. So what I've been doing the last 2 days is looking through all the data tickets and say that I ordered this. This is what I designed. Have they built it? Is it working? Does it produce the data? Is the data there that as I expect? Because I'm going to use the system later on. Can
you share anything about what the actually you made or you built?
What was the feature?
It was a box of lot of features, but it's for a big data real-time platform. So we ingest and we take like 7 million real-time events a day. 700 million, sorry. They come in a binary encoded format. It's very compact, condensed ones and zeros. We split those into records. We feed them into a real-time stream where we decode them in real time, and we enrich them. Because when we get the data, it's rather anonymous. It's an event that a SIM has connected to an operator somewhere and it doesn't say. It just codes. Okay, so we need to decorate this with, which customer does this SIM belong to, in order to see correlations between events and patterns on a customer
level. Can you be
a
bit, it's always nice for a listener to be, give some concrete example or something. What is an event,
An event is if you open your laptop here and you have a Wi-Fi, what needs to go on before you actually can go out on the internet is that there is some handshake between your client in the Wi-Fi client in your computer and the Wi-Fi router. Yeah. That's the same thing when you have mobile phones. Okay, so when you turn on your phone, it has to communicate and do some handshaking and say, this is I. Am I allowed to attach to your network? Okay, right. So in your room, when you go travel abroad, then it's even more complicated because then you can't just talk about the local network that is yours.
So one of these handshakes, is that an event as an example?
That's an event, yes. Yeah. Yes. So we can listen to this in real time. We don't tamper with information, we cannot, but we can sniff to it and package samples of it. Every single event is sampled and we get to start and end state of those milliseconds of the event, which means that we know what was tried to do and what the error code ended in. Okay, so it's, or if there was an error. So we know the state of the event, and all events, and those events then come in between 500,000 and a billion events a day, and those are the ones that we process.
And then basically, what is the business problem typically? I mean, like on a higher aggregated level, is it to optimize and identify deviations, fault detection?
So for our customers, it's just access to network, access to connected services. But from our end, we of course try to optimize that. Some customers want quality. Most customers want cost, low cost. And in order for us to deliver low cost, we need to also smartly choose which networks and priorities and so on. And that then we can learn from the connectivity pattern which are the working ones and where should we steer so on. Because we can do some kind of steering in this control plane.
So whenever a user is turning on their mobile phone or connecting to the internet, an event is being sent to Telenor network, right?
Yes.
Or it happens at Telenor. And
it's a request to attach to the network.
Yes.
Okay. And then because if you are just attached to that, someone want to get charged for your consumption there. Right. So the check that goes to us, the home network, is the one that confirms, is there a roaming agreement? Okay.
Right. And you have to identify the user, you have to know what kind of subscription they have, I guess, and authorize if they actually can be allowed.
And we don't do that. That's, of course, core components in the mobile network. So that's capture is done automatically. But what we do is that we configure what we prefer and what the customers says that they want to allow. Okay. Because they don't want very high expensive networks, for instance. Right. Okay. If they have a low cost product, they can't charge hundreds of dollars for a megabyte. It will kill the use case. So then they want only cheap networks, for instance.
But you can select what kind of plan that they should go for, or what?
We can control almost every single step of it. Mostly it's access. What most customers are buying is access to a market. So if they buy Germany, they don't care about which operator. But we maybe have access to 5-6 operators, and we select those based on our
based on the price point, quality of service, etc.
Yes.
I think people may not understand, how complex the whole mobile network setup is, but if someone has a subscription with Telenor and they are currently in Germany, you have to select some kind of operator in Germany that you collaborate with, right?
Not our customers, but if you buy a SIM card in Germany, you only get one operator because we have you can't roam in your country in Europe. If you buy a Telenor SIM, you can't use in Sweden. You can't use it to use Telia or 3 or Tele2. It's legally blocked by.
So you have your SIM.
Okay. So you can only roam to multiple networks outside your home network.
So you have a Telenor SIM in Sweden. It means that you can only use the Telenor radio base stations and network in Sweden.
You can try yourself. You can search for other networks, but it won't work.
Yeah, but as soon as I now fly and I touch down in Germany, and I look at my phone, and all of a sudden, I got Orange, or I got something, And that is something that is then roamed based on the collaborations that Telenor has with several German mobile operators. And in this way, if you travel across Germany, it might even be that while you're traveling, I had Orange in the south, and now I have Vodafone in the north.
So now you describe what is so fantastic with a roaming-based model, because then you can get access to better networks depending on where you are in a country. So this is what our customers usually look for. They want good coverage everywhere in all the parts of the world. And one single operator is not doing it for it. The second part that actually they are looking for is that if you're going to set up one enterprise agreement with one operator in every single country, and you are like Volvo Cars to deploy to like 100 countries. And in each country, you also need to manage like 1,000 or 100,000 of subscriptions. Right. When it's started, when should I just pause, when should I? You have like 100 different portals to log into. It's impossible. So what we have is one portal where you can control all of this centrally. So that's a logistical problem we solve for them. They get one invoice rather than 100 invoices.
But now, before we get into Telenor Connection and everything like that, I think this is the good time to basically start with welcoming Anders Bresell.
Thank you.
And what's your title now in Telenor Connection?
I'm head of data.
Head of data?
Yeah, I argued long about what my title should be, but my manager had the management said, no, you're known as data, Mr. Data. You're going to be head of data. So,
I love that. Yeah. Let's come back to that. But let's start. Who is Anders, and what is your story? How you ended up where you are right now?
Yeah, Anders. I live here in Stockholm. Currently work for Telenor Connection, but I started out somewhere in gymnasium and thinking about what I'm going to do, and I was kind of a lazy guy and thought maybe I shouldn't do as little as possible. But my mom convinced me at least apply for some engineering stuff. So I went.
Smart mom, STEM mom.
Yes, and so I took this natural science technology program. When that was complete, I was so engaged into technology and stuff like that. So I was 100% sure that I'm going to continue at a university in engineering programs. So I was interested in everything. So I took the broadest program I could have ever found. It was for engineering biology, because there you had physics, math, electronics, mechanics, and biology, and chemistry,
so
and physics. Engineering biology. It's civil engineering biology. So biotech, more or less, yeah.
And what university was this?
Linköping University.
Linköping, of course, the best one.
The best one, yes. It's a fantastic place. But yeah, so I went there, and it turned out that during those 5 years, I don't think I ever successfully, during those times, completed a wet lab with output that could be interpreted. It was like inconclusive halfway through. You had a 3 weeks lab, and you after 1 week, I won't get any result. You just continue to methodology.
So wet lab, I don't have green fingers for the chemistry stuff.
No, there was. I was really bad, so I realized this. I can build a career on this. So I had to do some more theoretical parts. So I started to go towards bioinformatics. So bioinformatics is taking biology problem and solve them in a computer. So I had to add some more computer science stuff and programming language and so on. And that was super fun. It was just emerging field back in Sweden then. Maybe this was around millennium, something around that. And I got the opportunity to go down to Lund and start at AstraZeneca, do my master's thesis with one of the more profiled persons, Bo Svedenius, that was a bioinformaticians that was speaking at different conferences and so on. So I got a master's thesis there, and he sort of mentored me about industrial scale research, and I was so amazed and said, I want to do this for life. Okay. But I also quickly understood that when he was mentoring I was a student, but he invited me to budget meetings and everything. Just you should learn about this. You should understand what's going on. And
fantastic.
And I did. And then I realized whenever both in the scientific meetings and decision meetings, those that were not had a PhD title, they had so little to contribute in the discussions. So that got me thinking, I don't want to sit there and just listen to the others. I want to
What kind of discussions do you mean?
I mean, it was like design of studies. It was why didn't it work? And so it was like all these problem-solving things about the challenges that the company was facing around the current business. They were like, okay, you decide and I go out and do. And I wanted to be engaged in those discussions. So I realized, okay, I love what I'm doing. I love to be a student. It's nice. Everything is cheap. You have good beer and lots of time. You can focus on the stuff you want. And I can do this for 5 more years and be a doctor in the end and get to my career goal. Okay. So that's what I did. I went back to Linköping University and did 5 years, learned machine learning on biological data.
Which department was that in Linköping?
IFM is in Swedish Institutionen för det mesta. or Institute for Physics, Measurement Technology, Biology and Chemistry, I think it is. And it's this cross-science, I think it's 450 or 500 back then. Lots of
and which years did you do the PhD between? Was it from 2000?
I started maybe 2002 and was done early 2018.
18?
Yes.
8.
2008, sorry.
Jesus Christ.
Someone is awake at least. Yeah.
No. Someone had a party.
Yeah, so
but it's almost at the same time. I started a bit earlier than you in Linköping, but I started in 2000. But yeah, I don't think we met at Linköping.
No, maybe. I was mostly. I had some connections at IDA. Paul Lambrix was my examiner for my master thesis and so on. And he set in place actually the profile of bioinformatics for my program. So what he did actually was me and some other students, we handpicked different courses from different...
and then you decided this is the curricula.
And then he looked at, okay, so there are many people that want to go this route and we create a profile on this and he... Yeah.
And what was your thesis? What was your work focused on?
Oh, it was protein sequencing, pattern recognition. So it was machine learning methods to classify protein families. And from that, you can draw insights from if one protein belongs to a family, you can transfer the characteristics or the functionality of that.
So let's go nerdy. What machine learning? What did you actually do?
Yeah, thank you for not asking about the biological part.
I went to the machine.
Yes. So, neural networks were available at that time, but we sort of learned in the field that they were extremely unreliable in that time. They didn't converge. Okay, they could luckily work, or they normally did not. It was so easy to overtrain them. So the best in class back then was usually support vector machines, and that's what I was really good at. That and building different algorithms to build different patterns to feed into this hidden Markov models, which is a very nice thing that you can use for sequencing. It originally comes from voice recognition. I don't know how the modern, but yeah, so that's the kind of technologies. So support vector machines was my and
what was the, humor me as the data illiterate.
I'm going to ask what that is.
But so what was the sort of data problem that you was trying to solve?
Oh yeah, that's probably why I left academia. There were no real interesting problems to solve. All the real problems are out in the world. Okay. Yeah. So this basic research, it was iterating on other studies to improve the models, increase the family, expand or current knowledge a little bit more, and squeeze a new algorithm out and tune a few percentage points on accuracy. It was, in the end, I thought it was very distressing.
I have to quote, we've done that a number of times, before in this podcast, but there is this famous person called Jeremy Howard, and he's the founder of Fast AI and also was the president of Kaggle before. And he made this quote asking about, what is the impact of, or, what is the academic research in deep learning? And he said, research in deep learning today is a complete waste of time. And if we try to unpack that a bit and just talk a bit more of what he said, it's basically that exactly what you said, which is that a lot of the academic research today, especially in machine learning and deep learning, is about trying to have half a percentage point higher for some existing academic data set that is completely cleaned up and perfect in some ways, and you just tune it in a way that is not of practical use in any way. There are other problems you should really look into. Would you agree with that?
Yeah, absolutely. I think the challenge, if you go into the commercial market, okay, so you can win in two ways. Either you are first with a product, or you are the best in the product, then, or you can be cheap also in commercial. But that's the way you win market shares. But in research, it's either you are first with something and you complete a new idea, but then you have the fight against the whole community that this is a new idea. It's not how we used to do things. How do you get acceptance for new science that never done before? It's like, so it's hard to prove that and get acknowledged for that. So it's so much more resistance to go and fine tune and tweak something that already works.
That's much easier.
Yeah.
But I think here I used a little bit of a rabbit hole here. We also have referred to Andrew Ng in this context, which is sort of a little bit like in my Doe told you so moment, but because he's an AI professor and he's a really well renowned, and he starts talking about data centric, or what's his word? Data centric
versus model centric. Yeah.
Data centric versus model centric, and where he sort of says, from his angle, well, there's so much better ways to improve the accuracy or the performance, or actually improve the use case outcome by working on other topics and use parametric tuning of the model. And I think this is from another angle when you go out in the real dirty world, which I really think is on the same core message here, that to master data and AI and to get to a use case in production. There's so many more things that is useful to do than to super tune 1 percentage point on the model. So I wish the academia could then study those topics and be mastering the surrounding petals of the core AI problem. Would you agree? Because I think that's the problem. Right now we're getting into other topics of organization, change, data.
To be honest, I haven't thought much about it, but I don't. It's hard to argue that you should put a lot of research money on machine learning and so on in academia, because there is now a commercial drive to build models. If there is an interest to build open frameworks and so on, and you're afraid that commercial industry will build models and frameworks that are proprietary and protected and will hinder further innovation. Of course, then it should be probably, but
this is another argument we've also had, that the whole industry is leading rather than academia.
Yeah, I mean, if you look at most of the modeling framework, they are not coming from academia. No. I mean, maybe they at some point, but they got traction.
That is already established here.
Yeah.
we have established it.
We speak about the AI divide, time and time again all the time. Yeah.
But what you're saying, you're coming it from a different angle now. I find that quite refreshing. We're talking about the same topics, the AI divide, but you're also saying, why should academia then put effort into this when the business is already doing it? And then yes, maybe they should, if it's about safeguarding openness and stuff like that. Mm-hmm.
But then it can be a consortium instead or something. So and maybe that is academic, I don't know. But
that has profound implication. How should we look at, WASP and everything we do in Sweden in terms of putting AI? What is AI research that is useful then? I mean, like consortium, maybe that is closer to the business, so that is very useful versus academia and all that. But the whole landscape takes a turn. And if you open up that hypothesis, I find it refreshing.
I'm not going to.
I find it refreshing.
Yeah. But I may be provocative, but as coming from academia, I don't think we're going to move away money from academia. I don't say that. I just say that's not the way. I would argue is the best way. You can do it, but I wouldn't recommend it based on what I see. But I don't have the full picture.
But let me just try to see what you mean, because I think it's a bit of a shame personally that academia has lost a lot of really talented people to industry, and they are buying out professors and PhD students time and time again, and I wish there were a clear role for academia in research, in AI and biology perhaps. But I think it's going in a bit of a wrong direction right now. So do you agree that academia should have a role?
Yeah, absolutely. But not about researching AI per se, because I think that will happen naturally anyhow in the society. What research can do is applying AI as we do in the commercial industry. Yeah, academia can apply AI to academic problems. Like how does we more efficiently diagnose a certain disease, for instance. That is an AI can do. They can analyze more data points, finding patterns that a human cannot see. That is a typical research thing that academia can. But it's not so much about developing the AI field as per se and spend X amount of money on just that AI.
So let's see if I understand it correctly. I mean, for one, you can take we just want to have better AI models in general versus applications of AI in biology or in medicine or in economics or in whatever.
Or even in governmental control or steering or advising or in public sector. I think you can use a lot of that would probably be a perfect place for AI to research for public sector, because that will not be driven by commercial.
I actually like this. What do you...
But I don't. I agree, of course, and I wish that would be the case. But it also, in my mind at least, it would be partly driven by industry and public sector, wouldn't it?
Yeah, it is.
But what is really the difference? What should really academia focus on, and what should public sector and the industry focus on when it comes to research in general? Do you have any thoughts about that? What is the best place for academia versus?
Academia's absolute best thing is to educate people and train them and get them really good at something.
But no research then, you mean? Or?
Of course, research is important. We need to solve a lot of things. I don't think the climate research, for instance, would have been driven by the commercial sector. Right. I mean, that's a super good example where academia plays a super good role. So don't take me wrong. I don't think they shouldn't do any research in academia. I'm just thinking about traditional AI problems that I think of. I don't say that academia would do better. I can think of, if I have a half important model concept I want to try, I can give that away to an academia and try that for like 6 or months or 5 years as a PhD or something and see if something out. But I don't have that patience to look if it actually flies and it has the value I hoped it had in the end. I need to have like this more rapid pivoting testing, hypothesis testing. Didn't work. No, test something new, test different. You need to move fast. You can't have this tempo that is so easy to end up in academia.
But let me try to summarize what I heard. Maybe I heard something different here, because I heard it like first of all, we are talking narrow about research, academia and research in relation to hardcore AI models or frameworks. And here is a little bit like the hypothesis that you're putting forward is that it's moving so extremely fast now with so huge money and resource team behind it from for instance, the big tech giants and all that. So to do head-to-head type, research against what they're doing is not really adding so much value. But as soon as you basically say, like, we're going to maximize the use of what the big tech giants are doing and their open frameworks, yada, yada, yada. But our main AI research will be how to cross-pollinate the intersectional innovation between the core AI research and these applications, whatever they are, that we want to foster and drive as part of the Swedish economy. Do you see what I mean?
Yeah, I think.
So you're saying, why do our research department try to go head-to-head with Google? You already lost that game 10 years ago. So why don't you pivot just a little bit and you work on applied AI together with your peers in another department?
Yeah, that I can resonate with.
That is what I heard. That is how I
and
sort of
that's probably it. I haven't thought about this before, so you helped me reasoning here. but that's how I think.
I think AI should be a part of any kind of field when it comes to any kind of science that we have in university. So that I certainly agree with. But there is also, I would say, a need for AI research in computer science, for example. Yeah. And having like pure AI research being performed by academia as well. The problem is, of course, that they are being, drained or extracted from academia into industry. But if we are still were to try to find a place, academia had a role that is hard for industry to take. I mean, one argument would be like basic research in general, long-term, 5 years PhD studies is, you can of course do that in industry as well, and many do. And I don't know, it's a super hard argument for me. I hope we could find a clear place where academia would find a role also from a pure AI point of view when it comes to research. But this is a hard one, because a little bit, if you can't beat them, join them and work in symbiotic relationship with them. And this, what is the symbiotic relationship between our academic institutions and the people that are seriously 10 years ahead? But also, if we take, in US, yes, in China, yes. But potentially in Sweden, I think, the universities are rather good in Sweden, and industry, unfortunately, not as much. So perhaps there's a bigger need, and we have rather good universities in Sweden. So there is a clear role, I would argue, to have both like pure AI research and also applied AI research in academia in Sweden. Would you agree with that at least? Or
I think so. Absolutely. I wouldn't argue against. Maybe I've done it during the talk here, but yes, I don't disagree with you.
No, so I think it's about the pivot of their mission and purpose, not about shutting down, putting down.
Something
not shutting down, but it's just in US it's really hard because the best way you can do research in US is one of the tech giants. Yeah.
Okay, so if you're living in Sweden and you want to be on the cutting edge, you don't have a tech giant in Sweden. Okay, you can then try to work with that. But I agree with that. But can someone work in an institution and in research today, like in Sweden, and to do anything value or of relevance without keeping their eye to the ground or the ear to the ground on what the big tech giants are doing? Can you do it in isolation?
Not in AI, of course. But in Sweden, I think, for long-term research, I think academia still have a good place to have.
You have the whole RISE Institute in Sweden, which is an excellent collection of people that tries to figure out the Swedish society, how it will look like and how it will impact and what current research is indicating, and put the research in place that is lacking in order for us to be a competitive country going forward. I don't know if they have the ambitions. That's how I interpret they would justify themselves.
Yes. I think that's a great example of what you want to do to try to make the research that RISE is doing a bit more applicable, but that's like circumventing the real problem, and the real problem is that universities are struggling to find a place.
Yeah. Yes,
and I think there is a place, and I wish we could make an even stronger case for what the place for academia and universities in Sweden should be.
Yes, I agree with.
Right.
Yeah. So it's definitely needed. Is a key component of how we bring Sweden forward, but how to do it in the context of all the components of the world and what the tech giants are doing. You cannot build an institutional strategy for AI research in isolation from what the tech giants are doing. That's, I think, can we agree on that?
Yeah.
Perhaps we're going down a rabbit hole.
But let me then take us back a little bit. Yeah. So we ended up to have a major theme around PhD in academic research and the path for academic research, which I think was fantastic. But what happens, when did you move out of academia? Why did you move out of academia?
The final years there at the university, you think about how do I get out of this? I mean, you want a title, you want to show for the world that you actually managed to go through.
But you were not long-term seeking an academic career.
I had fantastic friends that did it, and I helped them, and I supported them, and so on. But I couldn't find this future for myself looking for grants, applying for grants in order to get my salary. That is, I want to go somewhere that I can do instant impact and produce value at once, and that I've found in the industry. So I contacted one old friend that worked at AstraZeneca and said, I'm going to go on maternity leave, so maybe you can be a temporary employee here. And I got in there, and that's it. I had fantastic team there over at AstraZeneca. I was done in Mölndal after about...
And what year was this approximately?
2008.
I went right after the PhD.
I was 1 week in Thailand between or something.
1 week in Thailand.
And then back. And it was an amazing team of talented persons. Lots of good leadership around data and informatics, as we call it. Biomedical informatics was called the team. So we worked with clinical data and some preclinical data. So, but clinical means that data based on humans. In pharmaceutical industry, you also start with data on animals, and then before that you just use data on labs and tubes.
So here we are going down the process.
And
we have learned
but
the
this
trial,
was like sort of one of the last steps there. So
okay.
And that was so fun to work there. I learned new models and new algorithms. I have fantastic people to learn from. After a year or something, I moved up to Södertälje and Snäckviken there and the research site there. Moved to another disease area. There I was completely alone in what we nowadays call a data scientist. I would call a bioinformaticians a biomedical informatician or something like that. But it was a data scientist. I was that.
But you weren't working in a group of
I belonged to the biostatistics. And they were very pure, on their science. They were like, that algorithm guy there, he has no theory of what he's doing. It's like
the statistics guy.
Yeah. So I had the only way I was accepted because I had a track record over at Mölndal. They said, this guy, Anders, he's amazing. Or something like that. I may be bragging, but that's why I got the role. They didn't know why I actually could do it. But they know that it needed something.
So tell us a little bit, what is the contrast, the difference, what you come in now with algorithms versus the statistical team? What is the difference that you're experiencing now?
Statisticians, there are a few, but most of them are there to confirm a hypothesis. Okay, they postulate something. This drug is better. A drug is better than drug B. Okay, that's a hypothesis. And then you try to prove that, look at the data and use the statistics to prove it. Mm-hmm. So you always look for confirmation or deferral. while a data scientist back then, as an information, we looked for patterns that could explain things. Why was drug B better than drug A or something? Why was it because they used different populations? There wasn't, and so on. So we looked at all the different kinds and used machine learning to find patterns that statisticians couldn't find because they were using single-dimensional data, or models.
Set tests.
Yes,
tests
ANOVA and all that, and controlled for all the statistical correctness ever could think of in the best way to maintain the most interpretable power, or whatever you call it. Yeah, they were super skilled in that, but they weren't skilled in finding patterns and so on. So that was.
So you actually, this is actually two different problems you were working on solving.
So gradually, I built up the knowledge in Södertälje about this, and built up a small team there and got acceptance and so on. Eventually, I was moved into the global group there and got another fantastic leader that was a former colleague to me, James Weatherall, an awesome guy that is sort of my what I wanted to be when I was like back then. I mean, he was this ground-to-earth, fantastic guy, fun, super skilled, super efficient. He could run a meeting with 5 people, 150 people, and still doing notes and jokes, and when it's done, it has everything packaged as a perfect document describing whatever we did. So it was not like this. Can you clean this notes for me or something like that? It was never. He was this digital way of working was native to him long before we had stuff like Teams or something. It was we do this here, then everyone can edit the document at the same time. And during a video presentation or something, we edited the same document. That was 20 years ago. I don't know, maybe, almost 20
10
years
years,
ago. 10, 15 years, yeah. It was not so much heard of back then. And that I thought was great to see a leader that could master all of it.
Yeah, it's cool.
So that was fantastic. I stayed at AstraZeneca many years, did a lot of things, but in the end they shut down the research there.
Right.
Yes.
So then you have to think about
2016 or 15?
12, or the decision came maybe 11, but 12 was when I exited. I stopped after, I left after 6 months or something. But if as I told you before, I had this idea about my career. I'm at the perfect spot. I did a good career. I reached the level. We had this role of principal scientist or something like that. Someone that has super much influence on decisions and what you should know or what you should.
That was the career path.
Yeah, that's I was at that position. I could acknowledge for your skills and experience, but you have no accountability. So it was this must be perfect to be there. Yeah. But then you had to think about what.
And what happened then in 2012?
So 15 years of research that didn't result in anything. We were a really bad position generally in the industry, not just AstraZeneca. There were very, very few good drugs that were candidates to actually cure new diseases. And what the authorities were doing is they're putting more regulations. We talked about this before, more regulations, making it more expensive to do drug development and reach the market. So I saw a very pessimistic time there. So I thought maybe I should leave
the industry.
I really didn't believe we were successful, or maybe there were a few that became successful, but I was very pessimistic. Maybe we could have more new drugs on the market that was approved by authorities.
So this is 2012. Has it changed?
Yes, it has changed. And probably why when I left, they figured it out. So now they're successful. They're launching much. And just look at COVID vaccine. I mean, that's just amazing. So I'm very, very happy for them. And if I would maintain all my shares in AstraZeneca, I would be super rich by now. I didn't. So that was a wrong bet. But personally, it was not wrong, because what I thought about and had to force about, what is it that makes you tick? Okay, what makes you go with work with a smile, and what are the? And I thought, was it really that I was developing drugs for diseases or patients or something? No, it wasn't. That could be altruistic or something. Was it that I was really good in biomedicine or something? No, it wasn't. It was to convert value out of data, okay? And applying all my experience, processing, analyzing and drawing insights and visualizing data and building models. That's what triggered me. So when I thought about it, which different sectors have data? And there was a job fair over at Södertälje back then. They invited, companies to recruit these all 1,000 scientists and highly educated persons. So I went out there, around there, and of course, those that were more, it was most strategically, but I was at SCB and looking at and so on. Didn't really like the culture or the things that I was tasked in that team. I had a few consultancy companies that sound kind of nice, and I thought as a career move, learning new industries, moving into a consultancy business is a perfect because you're exposed to different sectors naturally. So I did that 3 years at Capgemini and trying to.
That's a way also to try out different industries.
Yeah, I took that as an investment. I was literally going horizontal career-wise. It was like nothing happened. I almost didn't get any assignments that was exciting at all. Because this was quite early. They were this hype curve of big data. I was out speaking to clients about big data, but did they invest in a big data pilot? No. It took me like 2.5 years. And the first that actually wanted to do a pilot on big data was Telenor Connection.
Oh, interesting.
And I did that together with a colleague for a summer, and we were supposed to prove 2 things, and I proved 3, and they were sold. So a few months later, they came back with an RFQ on a big data real-time platform, asking different vendors to suggest a project to build that. And so I designed that platform, and we won as that
tender.
gig, tender, and in February we started to build. And back then, I don't know any kind of company that actually had big data platforms in production, but maybe like companies like Spotify and so on. But none of these traditional businesses actually had. There were lots of pilots.
2012, right?
Yeah, there were lots of pilots there.
Yeah, Telia is quite early, but it's not that many.
I was at Telia just before that, so I know exactly where they were, and they had started, but I had so many questions. Maybe can't talk about this, but main argument, maybe it wasn't from Telia, maybe it was from my colleagues at Capgemini talking to the client at Telia, but why should we go to the cloud? Why don't we buy more of this super expensive database vendor? And I was trying to explain this, your data will grow, you will grow out your systems faster than you can order servers. And then you need to pay license on the servers, and you need to have IT configured. We don't have the time. We will have streaming data coming in. We will need to process, and we will go for cloud. We don't have. And the thing was with the Telenor Connection, we didn't have the legacy.
I recognize this.
Yes. So that's there's many things about my journey at Telenor Connection that I cannot see at many other places. Maybe that's where I picked it. But
because you could come in quite fresh.
Yes. So Telenor Connection, maybe you could come in a little bit to that. But Telenor Connection was invented somewhere 20 years ago as the business thing around roaming, global roaming with SIM cards. And Telenor Connection, or Telenor that back then, built the world's first management platform for global connectivity of SIM cards. It's called M2M platform. Which was a massive thing. We built it together with Verisure and Volvo Cars and so on as pilot customer. Scania were all of these very early on. That's why they're so good at this point. We started all this together when German car makers were not even thinking about it. I don't know.
Scania is one of the earliest with real IoT in the modern sense, so to speak.
Yes. And I found a number of good business models on top of it. So but back then we built this huge platform, a telco platform for provisioning SIM cards and managing their roaming profiles and all this, and sending invoices. And we were like maybe 60 persons, and back then.
So much fun.
Yeah. So and what was Ericsson doing? Yeah, they were outsourcing and doing operational stuff for telcos all over the world. So let's sell this to them and buy it back as a service, because we are not good at operating this. We had to build.
You
we
built
had to build
something
it.
and you need a home for this and went to Ericsson.
Yeah, so we had it didn't exist, so we had to build it, but we couldn't operate it, so we sold it and bought it back as a service. So now, Telia is running on the same platform, Swiss Telecom, China Telecom.
From Ericsson?
Yes.
But you built it?
Yes. Now it's, of course, something completely different, but it's we have always had a head start on the platform. We are the biggest, I would argue, at least in Europe, the biggest operator on that platform. And we are probably those that drive the requirements on that platform.
And this platform, what is the main sort of the core business problem? Is that roaming and handling SIM? What is it that is the platform does?
There is the
core.
Yeah, so it has a core. So like the database of the SIMs. But then the difference with a traditional business to consumer is that each subscription is attached to a person. So the person is managing the subscription itself. Or the company, if you have business card, but it's still persons, and you on behalf of that person, the company is renewing or paying invoices or changing the agreements or something. But that's humans. But when you go to machines, you need to orchestrate this not for just individual persons. You need to do this for many, many millions of exactly the same type of machines.
Like, for instance, many trucks in Scania.
So I would say that if you take Scania, I haven't looked into their setup recently, but I would say that they maybe have something 10, 15 subscription packages. In the subscription package, there are subscriptions. So all the models of one manufacturer, or like one truck that has the same modem, goes to the same market. They are configured in a subscription package. So all you need to do is changing on the package level, and all the subscriptions get the configuration
needed.
Yeah. So that's one way it solves it, which would not be really the same in other. Then you can what more? It's not a very rocket kind of platform. There are multiple alternatives right now out on the market, but it was one of the first, and you don't really move out of platforms like that. So it's a good model, it's a good platform, but it's not rocket science. It's probably rather outdated by now in terms of like REST APIs and so on. It's some old soaps and stuff, and they are progressing on that. Yeah, XML. yes. But yeah, it's. The platform itself is good, but there are other things that we actually bring to the table, and that is that the customer just wants one invoice, one place to order SIM cards. So if you are Scania and you ship to Brazil, you ship to US, you ship to Spain, you ship to Germany, you don't go and buy local SIM cards and all this and manage that. That's completely impossible to manage over time. So now you can buy one SIM card that works in all places. You get good prices because we have a good global footprint, so we can negotiate on behalf of you, and you can control this on a massive scale. And in the end, you just have one partner that you negotiate with, and you have one that you pay the invoice to.
So you become like a SIM card broker in some way to different markets.
And we solved one more thing. We manufacture the SIM card and we send it to your manufacturing facility. So you can mount the SIM card exactly at the time that you mount the modem into the truck. And
so you can do it as part of the production value chain.
Yeah, exactly. So that's in short what.
Can you go? I mean, this obviously is a big platform, a lot of data, and it needs to be real time as well. Can you perhaps elaborate a bit more on what are the top challenges from a more technical point of view in making such a platform work?
So, if we speak about the big data platform that we have at Teleconnection that we are using, and not the platform that Ericsson is that we are using, because I don't know how that actually is working behind the APIs. Yes. But as a global connectivity managed provider, what you need to do is, of course, you need to be better than your competitors. So how do you do that? You have you can have better coverage, but mostly it's price, okay, and or quality of services. So you need access, and what we do, we collect shitloads of data and analyze that and make sure that we are on top of all the decisions, to make sure that we always negotiate with the best operators, make sure that they have our customers always have access to the markets. Because that is the problem that they have. If they could do that themselves, it will take them tons of time, and they don't have the negotiation power. Telenor Group has operators in Norway, Denmark, Sweden, Finland, and many parts of Asia. That is something we can bring to the table. Scania would say, yeah, what can you offer for us? Nothing. You can offer, you want to buy data from us? Yes, you can buy it. But you don't bring anything more to the table. If you have something that we can negotiate, we can give, for instance, Orange the whole Nordic market as if we get access to their market. Okay, so that's how it works.
But what is the core? I mean, like the journey for the big data platform as Telenor Connection. Where did that start? Or
yes, this is interesting.
And what was the original founding ideas for it?
So if we go back to when I told you there were no real production big data platforms back then. Maybe there were, but I didn't know about it, and I knew a lot back then because I met a lot of different companies. But there was this killer use case, okay? The pain. You as a management contractor, you never want to sell on pain, but that was what got us going, okay? It's something called a signaling storm.
What?
Signaling storm or tsunami in the world of telecoms.
What is that?
So if you think about Terminator movies like the Skynet,
yes.
Okay, murder robots, T-800, AI controlled by Skynet. They go out in the world and kill humans because they are the ones that going to pull Skynet, pull the plug out of Skynet and so on. Okay, that's a bit scary, but that's not really what happens in the IoT world. It's rather the movie, Minions. The Minions, the kids,
the yellow Minions. Dumame.
Yeah, Dumame. Yes.
I've never seen any kids movies.
No, sorry. But there's like a sort of a semi-kind evil villain, and he's followed by very dumb figures.
Okay,
they're yellow and small. This is how the IoT devices are. They are super many, but they are dumb. And if they figure out to do something, if one of you, figure out to do something that is bad, everyone does the same thing. So the massive scale of small events causes a huge bad impact. So this is what happens if something goes down. Then 20 million machines out in the world doesn't have connectivity. So everything gets silent. When it gets back on, everyone wants to join and connect. And then everything is throttled everywhere.
This is the tsunami or the signal storm.
Yes.
So both in terms of when it crashes bad because everything crashes.
Yes. So everything crashes, everything breaks every time, always, at some point. Okay, yeah. And when it happens, how fast can you recover?
And then one of the problems is actually will create congestion because everybody at the same time wants to do the handshake.
So if it would be humans, you would be tired. You would not restart your phone more than like 10 times. I don't know.
But this one.
Yeah, I know. You're physically exhausted. But something that has a programming code, every time you fail to connect, you retry. It can go on as long as it's battery. And most of this stuff, have a petrol, you can, or plugged in the wall. But if you're battery, you die after some time. But all the rest, they just kept on hammering. And this back then, we didn't have no idea how our customers' devices were operating. So they were, every time they failed, or not always, but many of them, every time they failed, they retried. And it could be milliseconds or seconds. So then everyone that actually there were very few that actually came through back to the home database, the HLR, to actually get approval to attach. So everyone failed because everyone got stuck in the doorway in. And they retry. So we actually, Telenor Connection, together with the GSMA, which are the Global Standard Mobile Association or something, we came up with this guideline that is now best practice, where you actually have to adopt a certain algorithm on board. So every time you fail, you need to wait X amounts of time. And then if you try, you can try again. And if you fail, you need to double the time plus some random. And then if you fail 3, you do 3. So it's a back-off algorithm. Okay, we didn't invent it, but we formulated it for the IoT use case of CPS. And what happens then is that there are fewer devices that tries to go through the door. So eventually some are let in, and then the overall load goes down and everyone is let in. And this now actually goes faster if some of them backs off rather than everyone hammers all the time.
Of course. Yeah.
So this is, I guess, similar to when you order tickets back a few days, years
Going
ago.
to the U2 concert.
Yeah, exactly. So this was our problem. And back in 2014, this happened twice. And it was our customers actually that caused, I mean, I'm sure if I can tell this, but it was one of our customers that was causing this. And the Telenor Sweden network, not just our service, every subscriber in Sweden for Telenor was out of service for 2 days, 48 hours.
This is a big blackout.
Yes. And it turned out that it was one of our customers, and they have fixed this now, so it's super good. But that, we were completely blind. We didn't know who the customers were causing this. We just know that it was bad. So what we invested was the collection of the data of the control plane. This tried to attach to the network, the request to attach, and the request to attach to a data session, and the determination of all these small control plane events. That was what we invested in collecting in real time.
So this is a real-time data platform from the absolute beginning.
So this is interesting. I had to speak at a conference many years ago that actually reflected it. We didn't start with business intelligence, moved into analytics, moved into machine learning, and then AI. We started with, and then moved into real time or something like that. Yeah. We actually started real time, and as a consequence of having shitloads of data in real time, we also got big data.
Yeah.
And on top of the big data, why should we try to build business intelligence on numbers that people made up in Excel? Now we actually have the actual events and could build business intelligence on top of the actual event level on the big data platform. Yeah. So we turned it a little bit around. It wasn't a thought about it. It was a way to solve and deliver business value.
So your evolution came from the core event rather than from another angle.
Yeah. So we always had real-time data.
So what do you mean? How do you fix the problem that was causing like 48-hour blackout? Was it like rate limiting a certain type of requests, or what was the solution?
It doesn't really solve the problem. There is rate limits, of course, but now you have to work with the customers. You need to have good collaboration. And now what we do is that we sign a contract with them. They have to. And if not, we are entitled to terminate their SIM card.
Oh, really?
And we kill it. We don't just pause the subscription. We write over the identifier, we write 0000000. So if you use that, it cannot be routed to us.
Really?
Yeah, so and as a way to, when you get in the signal storm, to basically get SIM cards to back off.
Yeah. They will go nowhere. So if they are now roaming in Poland or something, if it has a 000 identifier, it cannot be routed to us. So the Polish operator will not send it anywhere. They will just throw it away. So
awesome power that you have.
Yeah. However, I don't think we have ever done that to terminate the customer SIM. We actually talk to them first, and they update their firmware and fix this problem.
So typically there's something that happens in one customer's firmware which has nothing to do with the whole system that causes an event storm, an event chain.
Yeah. So this is interesting because you only see this problem when there is a disturbance. When under normal operation, this is not a problem.
No,
I feel I recognize this problem. Whenever the system is working perfectly, you're doing the right job. But whenever shit hits the storm, you get blamed for it.
Yes,
I recognize this for some reason.
It's same in job,
Could you speak, for people that are a bit tech oriented, how do you handle 1 billion events per day?
Yeah.
Can you, what kind of tech stack do you have?
So touching back on that, we didn't have any legacy. Okay. So where do you start if you develop something? Back in 2015, 16, you go to the cloud. And which cloud do you take? Well, back then...
But you made a cloud choice in 15. This is quite early.
Yes.
Still, I would argue.
Yeah, that was one of the hypotheses that I tested. Was AWS the right cloud for addressing that? Or would it work for addressing our... and it did. 2016 was when we started. No, 2014 actually, sorry. 2015 when we started to build our production system. That was in February. In June, end of June, we launched it into production.
Really?
and went live.
That sounds too good to be true.
It did, and I was so proud of this.
But let's, because I realized that AWS is a huge tech stack. So let's go into a little more detail.
Yeah. So first of all, the control plane events is something that we fetch from the core backend of Telco Stack. Those are streamed up to AWS in the cloud.
S3 bucket or something like that?
No. It's a TCP/IP binary stream.
Okay.
When you look at it, you don't see the start and stop of any record.
Okay, so pure event.
Yeah, so if I don't know how deep I should go here, but
please,
we have
Go nerdy. We want to go nerdy.
Okay,
We've been missing the nerdy pieces.
Okay, yes. Okay.
So go.
So what happens first is that this TCP/IP stream that contains the binary encoded records of all the probes, the samples of the events, those are streamed. They are streamed to a single EC2 server, where where there's a Java application just listening to the chunking this in real time, just a CPU more or less, that chops up and listens to the start and stop of any record.
But you can at least recognize the TCP headers and stuff, right? Or you must.
We look at it's just a binary sequence of records. We look for the record definition of a start, so the hexadecimal code. We're eating bytes or
But at least, otherwise, it's going over the internet, so you have to have TCP headers at least that you can.
But it's a socket stream.
Oh, it's a socket stream over TCP. Okay, so you look directly at the socket stream.
Oh, you can't have the overhead of HTTP headers and stuff like that. No, this is a TCP. So it's a binary stream.
Okay.
Socket based. So that's why the probe listener, as we call it, the probes are.
By the way, what's the difference? So the header, you go on high level, or you go more binary? Could you explain it?
A socket, you stream data. It's like if you stream a movie, you don't do HTTP requests saying REST API calls for every single frame.
No.
Okay, that won't work. So you stream it through a socket. That's more or less.
I think it's still TCP package, but it doesn't matter.
Yeah, of course it is. Yeah. So there's handshake of every package. Yes, of
exactly.
course. Yes. So that's true.
But it's not a new HTTP request. It's a single HTTP request. It's just streamed over that.
Yes. So if it goes down, it connects back to the source.
Yeah.
So those. So we split up this binary sequence of ones and zeros into what we know is a start and stop of records. So we don't split one record in two.
Right.
Okay. Then we microbatch this, and every microsecond or something, we then put this into a kinesis stream. And kinesis is similar to Kafka or something, but it actually has a way to process the data in the other end that is very powerful.
So it's an Amazon version of that.
Yeah. It's I don't know if it's Kafka is like event driven, but this is actually. We do batch of binaries that we put there, blobs, in the kinesis stream. It's not events there. When we consume it in the other end, we have a binary decoder taking these blobs and run them through a decoding step. And then we can build up something like a data structure that we can say, okay, this field here means a SIM card. This here means an operator. So what we then do is that in real time, because this is anonymized, this is sent from all the networks out in the globe. They don't have any knowledge about which SIM belongs to our customer or which they don't need to identify themselves. They just say, this is my ID. So how do we distinguish between the different IDs of operators? And there are like 4 or 5 different code systems that they are identified by. So it's a massive. So what we do is that we actually in this is a Docker cluster that consumes from the kinesis stream in real time.
Kubernetes based or just
Docker.
Yeah,
Docker. We can go into the engineering part of it. I'm not. It's actually a Fargate, if I remember, which means it's actually a managed cluster. So we don't need to maintain the cluster itself. But it autoscales, goes up and down. So during nighttime, it's of course less load and so on. But these decoders not only decode the binary records, it also maintains an shared in-memory reference data that this IMSI, for instance, because you will see this IMSI SIM card ID for
yes.
So SIM card ID belongs to this customer. You need to know that every time that comes up. So we maintain most of the events that we need to look up in memory with the shared memory in the cluster. And those that we don't can fit into the memory that are used very seldom, we look up in Dynamo DynamoDB, which is a key value store that scales extremely well if you design your keys in a smart way.
Right.
And we've done that.
So key value store that is optimized for Amazon's use case.
So at this point now, you have a CSV row, more or less, with the timestamp when it happened, the type of event that happened, the record type, the customer ID, the customer name, the operator ID, operator name, etc., and error codes and stuff like that. So this is our main data. And this is now, what do we do with this? When we throw that into a second sequence of multiple streams, and we're using Kinesis streams, we're using Kinesis data analytics to do real-time aggregates on this in multiple ways. So one is just to calculate an SLA service objects based on this.
Okay. You have SLA on this as well, I guess.
Yes. Not on the platform, but for our services to our customer. But we calculate the service object based on actually monitoring the real-time data and producing.
So this becomes your metric of if your SLA is up or down.
Yes. Yeah. So we started down to 5 minutes, and I collect. Can we prove that a SIM card could attach to a network? Could it send data? Could it send SMS? Did it come through? And so on. So that's one way, but that's a minor use case. Then we have, actually 5 or 6 different protocols that we ingest through the same TCP/IP stream. So it's actually 6 different protocols: one for data, two for data, one for SMS, and 2 for attaching. So 2G, 3G is one standard, and 4G is another standard. They behave similar, but they're completely different. So you need for control plane 1 and control plane 2 doing data is 4 protocols, and then we have SMS, and then we have actually throughput, so we can listen to how many bytes actually in a data session down to a second level.
And this these kind of support for different protocols is being developed, I guess, in-house on the Java?
No. This is a product we buy, and most telecom operated by this. It's a Swedish company called Polystar. They are super awesome. So they have this built. They are world leading in this business.
Nice.
So they had the whole streaming. They produced the stream for us, more or less. So
and is all we talked about right now, and the whole event from the start to the all these different levels, is this all more or less real time, or is it when does it become batch or micro batch in this?
So it's not. The aggregates, as soon as you start to do real-time aggregates, it becomes micro batches. But what we also do in real-time is that we send all the events. No, exactly. We do real-time feature engineering, or we produce the features in real-time in this case.
What do you mean with the features? In this
so
sense?
if there's an event now, we construct. We can't do modeling on each and single event or so. But for maybe how does the number of events for a customer look like in one country, for instance? That is a feature. So maybe how many events and how many errors. So very simple features. So those we construct in real time in Kinesis data analytics, and we run them through random cut forest models that are trained on the time series that are buffered in the time stream. So then we get out an anomaly score saying high or low if this combination of different features on customers or operator level is anomalies. And then we put this score through a rule engine, which is just a simple lambda. And if this reaches the cutoff, we will create a new record create an alarm in a DynamoDB record. And on top of that, we have a simple web interface with a list of alarms, which we present to our service operations center, and they look, okay, anomaly.
What is the lambda here? Explain
lambda, sorry, good. A lambda, so if you think about servers, and if you are more modern, you do like Dockerized solutions like Kubernetes or Docker. But if you go to the next step, you just deploy the code, the function. And this is a function as a service, and it's super elegant. It's serverless, and you don't even need to provision a cluster or an image. You just provide the code. So you say, I want to run my code as a Python or Node or Java or anything, and you just put the code in, and you can have a trigger to invoke the function.
So serverless, you're talking about.
Yes.
I think for people that don't, is not familiar to cloud computing, I think it would be nice to just, explain a bit the different levels of abstraction you can have.
Yes, I think this is good.
for one, you can have the hardware level, doing nothing on the cloud and then having to manage all the hardware itself, the hard drives, and updating the operating system and doing all that kind of work. You can abstract it away with cloud computing. So you can have them operating the hardware, and they will fix the hard drives when they break and everything.
Infra as a service.
And that's nice in itself. But then you still have the operating systems. You need to update them all the time and fix all the security bugs coming all the time. But then you can have Dockers, and it can abstract that away. So then, great. Then you don't have to care about that. But you still have to deploy the application in itself, and you need to continuously update that. But then you can abstract that away as well and just go from the application to the function as well. And then you come to the serverless kind of abstraction that you're speaking about, which Lambda or Google Cloud Functions.
Google have functions.
Cloud Functions.
Lambda is the AWS speak lingo for this.
Lambda is the serverless kind of architecture, yes. So you don't have to care about deploying the application.
So you don't need to maintain servers, you don't need to maintain operating systems, you don't need to maintain the runtime environment.
Yeah.
You just put the function in. So these are super good for small, short-living functions like processing event. So for a rule engine invoked, every time there is an output from the Kinesis Data Analytics of a feature, calculated with an anomaly score, it is thrown to the Lambda, and Lambda says, okay, is this score high enough to create something to tell the business about? If not, throw it away.
And I think this is quite important also, because all these different when to be on different abstractions, what to use. I mean, like a core topic, just to reflect a little bit, is that you really need to know your data problem quite well to select when do I use the Dynamo, when do I do a Lambda and all that.
And we have done so many mistakes during these 6 years. We are actually now on our third generation big data platform. Yeah. So over this, so the first one was super dumb in many senses, except the streaming part that I described initially. This up until the decoding, that is more or less. It's a little bit more advanced. We re-engineered it last year, but it's pretty much the same design. But most of the other things we have evolved over the time and changed, and have lots of reflections over those parts of it.
But this is profound, because now I have an hypothesis, because I've seen organizations that start on big data projects and they sort of almost go dogmatic on their original ideas and architectures too soon. And it's a little bit like, no, we can't do it like this because that's not the architecture we chosen. And what you are saying now is that in 6 years, it's actually your third iteration of the same stuff. And would you say that is fundamental way of working, that your big data platform cannot stand still in a freeze moment? It becomes obsolete immediately.
Yeah. So there's a combination of things. Big data is costly, especially if you do it wrong. But if
that should be another T-shirt.
Big data costly if you do it wrong.
But if you don't have anything to compare any benchmark against, I mean, you can build something and it will work, and that's what we did in Generation 1. And we spent weeks and months to set up on-demand Hadoop clusters to run batch reporting, and in the end, we just throw it out of the window. And invented something.
Please, more people need to hear this and understand that you're not doing wrong when you throw shit out. It's part of the process.
So the trick here is I managed through the years to argument a combination of new capabilities and removing bad components in the solution that could be better designed. So if I usually don't just do one of them, I package this normally into investment projects that lowers the infrastructural cost and the computation cost, but adds capabilities and gives a higher business value.
And I think, a lot of people have invested in Hadoop and that's gone, the route that you just said. Big data is costly, especially if you do it wrong. But
this is important because I want to say something. Okay. The most painful thing is that our time from an idea to actually see the result of it was so long. So you almost got tired of it. That was killing the innovational capacity or capability and willingness to improve and test things.
So what's the alternative you would say to this today?
So I'm not expert on Google, but I think the BigQuery stuff is probably there. In Amazon, they have super cool things. They have something called Glue, which is a serverless way to an implementation of like PySpark and Python. You can run lambdas, you can run batch shape jobs in containers. You can also run PySpark clusters on demand. So this is a framework to run and orchestrate things. And that is for the processing part. But what we actually do for querying is that we use Parquet formats on S3. On top of that, we're using the Glue to create data catalogs automatically based on the data streaming and the processing into the data lake. And
the data lake is S3 in this case?
Yes, it's S3.
Yeah.
And this is the data lake that we have full control over where we store. So I don't know if it's a data lake in its general meaning that you dump any kind of data there. We know exactly what's in there, and we index everything by time point. So we know that if we're going to look for something, we can only look at this small part here. So then we use something called Athena. Then you can stream. This again is, so when you query something, when you know where the data is located for your query, you can go only there. And then you don't need to move the data anywhere. You just attach a small, and this is probably how it's implemented. You attach a small lambda, a small infrastructure component that has the method to read just that data object. And then it scans through that data object for your SQL query or whatever, and do the map reduce and filter up the data. And then you combine all this in parallel. You can do this millions of times in parallel for all your data objects everywhere in S3. And it's significantly faster than Hadoop, how we use Hadoop. But you can scan a few terabytes in almost nothing. And it's cost, and this is beautiful. Why? What do you pay for? You don't pay for infrastructure. You pay for the bytes you scan.
Yeah. And the core components then is, for one, I guess you have on S3 files stored in Parquet format, right?
Yeah.
And then you use Glue, I guess, with PySpark, etc., to access that, and then you can really find.
And on top of it, we actually have Redshift cluster.
Oh, you have that as well?
Yes, because that's the generation 2, and we haven't cut that. And it's actually a magic, fantastically database. It's so powerful. It's just very costly.
What do you store in Redshift then? I mean, it can't be full data. It's just the metadata.
No, we store 2 to 3 days of data of all the events.
With full content as well? Or?
Yes, everything.
Oh, really?
And so we actually have two big clusters. One for the real-time events stuff and for troubleshooting and for analysis of behavior or patterns and so on. But then we have the business intelligence solution where we collect all the things, where we collect information about calls and all the nitty-gritty details of every single call in an invoice. That is, we have I think we have a few billion calls every month or something like that. And those we store. We process them right now through Redshift. It's so bad, and we're going to remove this. Mm-hmm. We're going to use this pattern you just described with Glue and inject it on S3. It's so much cheaper. Yeah. But in generation 2, we actually found this fantastic pattern to add new data streams. So we generalized the way to process any kind of data stream inside a database. So we developed like an application in the database where we have like import, validation. If it wasn't meeting the criteria for valid for a report or something, we quarantined it. And because there was like reference data missing, we could repair it over the night, do batch up, and then we moved into valid. Valid was everyone's like goldmine. There you can analyze everything. And then we aggregated predefined features that we always wanted to have in longer pen. And after 2 days or 3 days, we removed it down to S3 again. And then we index it up again through Spectrum, so we can query it through Redshift on S3.
Spectrum, is that another Amazon service?
It's actually Athena inside Redshift. So Redshift is a columnar database. It's extremely powerful.
I love that you actually could go so deep in tech here. I think we lost a few people. That didn't, but I think we gained some other people.
But you know what? Let's wrap this up a little bit, and in relation to what are we talking about here, and why is this a very important conversation? Let me take my take on this, and I see what you say. Number one, the technology we are dealing with is moving so fast now, so you need to kill your darlings, and you need to constantly understand, how do I reduce cost? How do I increase efficiency? with a laser sharp understanding for the business problem and the data problem. That's my first post. Is that true?
Yeah.
I mean, because I don't see people doing that. I see they getting stuck in their old Hadoop, or they're getting stuck in their new, even Snowflake. I don't care, but they're getting stuck.
Probably a good product. But
I mean, it's a great product, but it's the mindset on technology.
No.
Well, I have conversations where people, oh no, that's not part of our guardrails.
No, I think you need to every day, challenge what you already done. Why should we do it like this? And at least my brain works like this. You question the things that you don't think you do good enough.
Yeah.
And then you look at the things that you would like to do that you're not doing today. And then you look at, okay, what should my use cases that I want to carry forward and continue to do? And what are the new ones? And what would the solution look like that does both in a good way, or support, or like it does that in a scalable way? And then you come up with a new solution that lowers the old cost you had, but it enables your new use cases also.
Okay. Now, second topic that I've been biting my tongue, that has been, while you were talking, I have had one question in my head the whole time. How the fuck did you sell it? What is your storytelling, and how have you packaged the storytelling to get, the funding? So I think you said it a little bit like you were onto it a little bit like, I reduced the cost here. I put in a package. This, to me, I think a lot of people who are working on this, they dream about going in this direction, but they don't have the rhetorics to make it happen from the funding perspective or whatever reason. So what have you done to succeed? To
show value.
Yeah, okay.
Go to production and show value. And make sure that you engage and understand all parts of the business. If you do that, you can present solutions to almost everyone.
Okay.
And then you have everyone supporting you in whatever you want to do. And when you come up with a suggestion, you can tie it to a business need. And it's not hard if you have a whole business backing up of different use cases to pick those that is valid. But I can say the last time, I don't think we really fighted for the business case at all. I did lots of preparation, but in the end, I just referred to 2 cases the past year, what my team and the platform have resulted in. I said, here we saved 2.5 million of revenue leakage, and here we stopped 8 million yearly bleeding. And that was by coincidence, because we looked at the data. And this is the value. Okay, if you want to modernize and you will take like 3 million here, go ahead, says the CEO. And he stopped me after 10 minutes.
But okay, and here we have now the big divide, that how many tech platform people can connect like you. Now, maybe you have an opportunity now with the data like you have, but sometimes that's really hard to connect so strongly. I mean, like, I think you're saying the right stuff. I think that's the advice we need to give to our listeners. Connect to your real business cases, of course.
Yeah.
Not all, but to get that done, if you're in the tech IT environment, too far removed from the business application, hard.
Yeah, but I don't know. I mean, you can use all these frameworks. I think they are good. But if you have this unicorn that has the passion, understanding for the business and the problem, and you have the tech understanding, and you have the data understanding, if you create a team of people that can do that together, that don't have any communication barriers,
That's cool.
Then there are no blockers. I mean, you can just show the value for someone that needs to pay for it, and it's done.
But let's try to capture that into a separate topic, I think.
Yeah. Let's go there now.
Yeah. We have I feel a bit poor for Goran, and later we have to group this into topics. But if we try to phrase a new topic here, and that topic could be basically what we just spoke about, which is we want in some way to foster data innovation. How do we capture being able to innovate when it comes to data and AI properly? And there are a lot of issues here. For one, we could have people being isolated in different teams, and they don't have the mandate to really come up with good ideas. And you could have problems with building a lot of prototypes that never comes to production. and you could have problems with not having the critical mass to actually have the infrastructure to do something that really works, etc. What is your secret sauce, so to speak, to be able to come up with, let's say that you and Telenor now have, someone in your team or yourself or someone has an idea, I really want to make this change. I think we could have an awesome improvement in revenue and value for the company in the end. But then you need to really make that happen somehow. And I think for most companies that fails. But how do you think, what's the secret sauce to success here to innovate in data?
I mean, I don't think you can, in 1 or 2 or 3 meetings, convince someone that doesn't understand anything from start. I haven't seen that. In all my places I've been, it's a matter of building a personal brand, understanding the business, learning, and starting with
personal brand. You mean that people should, demonstrate by previous success in some way that they have been able to do that, and that way they gain some kind of mandate, or what do you mean?
Yeah, I think that definitely helps. If you just refer, are you trusting a method or are you trusting a person?
Yes, good question. Good question.
I mean, most decision makers wouldn't understand any methods that are in a data or AI. Yes. Okay, so yes. But if they trust you on your recommendations, so here's what I think. What I've learned is working for decision makers. If you're an expert, and if you're going to present a big data or AI project or a solution, and want money for it, then you're an expert on that. The decision makers are likely not. So you need to understand then how they're thinking about the decision. They will trust you as an expert. So they're not distrusting your expertise. They are distrusting possibly your assumptions you based going in and define the solution based on your expertise. Okay. So what you need to do is you need to ground your assumptions and say, these are the assumptions I made when I recommend this.
I love this. I reckon this is profound.
So for instance, what I usually do then, okay, we have 4 years of track record of amazing output, saving money, helping customers, step change of quality. That's what I'm going to. So if you think that we're going to continue to do that, and if we invest more here, we can be better. If you think that, then this is what I'm recommending. We're going to do this. Okay. Yeah. So that building on history. If you don't have history, you will say, I think that our data, my assumptions, the data can help us improve quality or improve processes or something like that. Yeah. That's what and there are evidence suggesting that it's possible because lots of companies have done it, Facebook and Google, and okay, that's your assumption. So now I go in and say that we are capable of doing this, and I am an expert, because that's what you need to say. You're going to trust this person, I think. And if you assume that what you're going to say, they're going to question, they cannot even question the assumptions, but they will probably say, have you thought about this? How are we going to charge for it? And so what's your business model? And then you need to think about that. So that's the way. Think about the assumptions that you made and be clear, because that's the way they can fight you down.
I really like this advice, actually, because I think we are failing sometimes because we are so proud experts. So we think we're going to go up and pitch the idea. And with the simple assumption, well, they don't really understand, and they're not there to question you on your expertise. They are there to play on their playing field. And what is that going to be all about? The assumption, yada, yada, yada. So I think that's where we fail. So what you're saying then is like, when you want to sell to the stakeholders, make sure you do the problem framing. Make sure they buy into the problem framing. That's where you spend all your time. Yeah. And basically, is this the problem we should solve? Yeah. Well, how much is this worth to solve this problem? What are the alternatives to solve? Then the recommendation becomes, well, I think I can solve it.
And then is that really the case? I mean, for one, you need
it's more complex.
For one, you need to define the problem, obviously. But you said something that I think is also interesting, which is that if you have a person with a track record, a person that people trust, it will be much easier as well.
Yes.
Right?
Then it's almost no resistance.
Right. So then the problem is the opposite. If you have people that may not have the track record, how can you still keep?
That's where the assumptions come in. Because
Yes.
Assumption that I say that my team has delivered something historically is probably a very valid assumption.
Yeah.
But if I haven't proven nothing, then you need to say, I have a team here with these skills. My assumption is that these skills are the right one. This problem to solve is the right one. That's my assumption. There might be others, but I think it's worth solving. Okay, that's an assumption. So you can start reasoning like that without any evidence. The second thing I think we can think of is, what happens if one of these or several of the assumptions are wrong?
Exactly. Yes. Now you're getting to my point.
So then you go to the next level. So you frame the problem, assumptions. This is what I think, what I base my recommendation. But what happens if this is wrong? At most, it will be we'll learn something for 1 million SEK. I don't know.
Yeah.
I don't know.
Okay, but now you're getting actually to my point. And what I would like to get at is that there are so many ideas that come up there. And sometimes you invest in these kind of super huge projects that can cost millions of crowns or more. And that can be costly, and that usually a lot of companies do that, and they start with some single prototype and they try to make that work, and they didn't make it work the first month, they didn't make it work the second month, not the 6th month, not 12 months later. Yes. And then they said after a while, I don't think this thing with data and AI is really for us. And in my view, this is a really scary situation where you don't adopt this kind of failing fast idea. Would you agree?
Yes, it's super important.
So I think potentially we need to have a mindset, I think especially of the management team, that you need to try a lot of things and expect that most things will fail. And basically assume and be perfectly fine with that most experiments will fail. And then have a quick way to do experimentation.
Yes, and they should be cheap and fast.
Yes,
hopefully. And sometimes you bet a little bit more, but the stakes may be higher.
But now we're coming to a really one of the real big challenges. We are coming in the difference between startups in many ways and the big industrial companies. The big industrial companies, if they've been around for 100 years, they are in the mature macro. Their industrial life cycle is mature, right? So they are very much plan-driven. Budget, everything we do, I sell trucks, I have a stable supply and demand, I plan. And what we are dealing with now, both in terms of innovation and experimentation, but also in the core dimension of how AI is built, is hypothesis-driven. So all of a sudden now, the whole steering model in a lot of enterprise organizations are plan-driven and not hypothesis-driven. So I think here this is one of the root causes around culture around how to experiment. It's not okay to fail. I have a business case and all the things I do is waterfall and they should have success. I plan and I deliver, which is not. It's a very different culture. The mindset of the executive is very different, Anders, to do what you are asking.
It is, but let me phrase a question to you, which is a bit provocative, and see what you think about this. I think you will say something else. But anyway, what do you think about building prototypes versus going to production directly?
I would probably spend super little time on the prototype and try to move it into production. But maybe I'll spend quite much time moving it in production. So it will be long time scalable and robust. But the prototype is just removing the most obvious uncertainties. It's not proving the concept per se, because the concept I think you need to believe in some way, and you must be rational why it's working, I think. But the prototype is okay. Is this the right way of building it? Is this the right way of solving it? And try that very fast and say, okay, using these two different services, we can combine it and use this yes, it works. There's no there are no scalable problems here, so this is probably a valid way forward. So it's about navigating, not a toll gate to do it or not. Maybe that's one way of seeing it.
Yeah, I mean, the reason I'm saying this is because sometimes I hear people saying you should always target going to production directly, and I actually have a problem with that, and I think that's a problem. The problem is that people don't realize the complexity of moving something to production. And if you mean truly production in any kind of reasonably sized company, is super huge amount of work to move something to production.
It is. And we had this.
Yes.
In generation 1, definitely. In generation 2, slightly. But in generation 3 now, we are thinking about every single use case as a separate infrastructural independent unit in one way. It's all coming from the same stream, but we fork it off. So if you do something, it doesn't tamper with anything else in the production platform. You add capabilities. And the same goes for this race for condition or race for resource condition, which is a classical problem when you want to touch same data points a lot of time. It's throttled. Or, I mean, if everyone wants to connect to the big data solution through this SQL client, this Redshift cluster, and run queries at the same time, it will not work. So that is now a solution we are trying to build slightly away from for most of the use cases. For the classical BI, it's perfect, but not for processing and analyzing stuff that spans a lot of data. Maybe that is better to do as a standalone job that is temporarily getting its own infrastructure. Or is based on a database solution that scales on request and not on the storage.
So what you're saying is going to production, yes, but we are not going in a large scale production, but we're trying to be modular in our strategies, so we can take smaller pieces of the story to production.
Yeah, so maybe I skipped a few steps, but the first thing I think is extremely important is that you build an architecture and rely on that, and an architecture that is addressing any kind of use case. So you don't build it for one use case only, you build it for capabilities. And then when you have a use case that you want to go to production, then everything is ready in the platform to add that capability and use that capability and build a third capability or something. So that is something I don't build features normally in terms of software, I'm adding capabilities, and the user is normally defining the use case after I've designed the platform. So this is the classical problem of business intelligence. I designed a report and you spend shitloads of money to process data and it comes out exactly as you defined. And then the user decides, but I would like to have by month here or like by shop or something, and it's not in the data. So they need to go back, and it wasn't even collected in your cube and so on. Then you need to go to the source, and it's so much work. So, everyone should be able to produce a report of everything. And how to do that is establishing the data in a good
Perhaps
story.
we're speaking a bit different things, because it's one thing to do it in a report and from a BI point of view. It's a different thing if you actually have to integrate it into a proper product or mobile app or web content and system. And
I'm afraid of customer-facing solutions. Yes.
And for that, I actually would like to disagree with some actually talks I heard recently in the Data Innovation Summit that otherwise was great, of course. But some people that claim that you can go directly to production, I would strongly disagree with. And I would even go to say that these kind of 3-stage or 3-pronged approaches where, first you try to have a very quick prototype that you try to demonstrate a value for, you need to have, because normally 80-90% will fail, and you can't do that by taking 10 things to production. That would be extremely costly. So you need to quickly fail, and you quickly fail by first doing a prototype. Then you potentially do a pilot, which is a minimal kind of integration to production, but very far from a full production implementation. And thirdly, potentially do a production.
Yes, and you're probably exaggerating, but going to production is, of course, it comes with lots of blockers and toll gates and so on. And especially if you're a serious company with business processes and you have standardized certificates of ISO 9000 or 27001 and so on. We have those. And you don't go to production whenever you want.
In terms of service agreements, and the legal department needs to be on board on it.
Yes, and you need to announce service windows and so on.
And you need to fulfill the GDPR kind of requirements.
Yes.
And if people just realize the immense amount of work to putting something in pure, proper production, they wouldn't say you should go to production directly. I must say.
All right. But time is flying, guys.
Yeah.
So I actually want to go to the next kind of topics right now. I think this was a good conversation. I mean, there's a couple of core topics that I want to talk about. First, I want to explore more edge intelligence, AIoT, 5G. Where is the whole industry going here? I think we could start there. I also want to explore some of the publications you have done. I mean, like talking about lessons learned from how to succeed with data and AI, what you have seen working with your whole customer base and all that, because you sit in a unique situation that you see AIoT data projects that your customer is doing. So those two topics I really want to explore to some degree.
Cool.
I think we should start, moving from the Telenor and what we have talked about now, and then go into, how do we understand this industry or this marketplace, IoT, 5G, edge intelligence. Please start in whatever angle you bring the game to the industry.
Yeah. So it's a diverse market. It's everything from connectivity to hardware architecture to how you feed and send the data, where you have the business logic, the decisions in your automated systems. All of these are a lot of parameters that is different for every single IoT solution. We learned this one of the hard ways, I would say. We built a horizontal offering for setting up new IoT use cases.
The horizontal
platforms, yeah. So
what do you mean horizontal?
So you submit data to a platform and you can build your application on top of it. We take care of everything. Provision.
So you build some sort of middleware.
Yeah, so everyone needs to provision a thing. Mm-hmm. Everyone needs the communication channel to the thing. Everyone needs a user management system, and they need some kind of domain model who can do what with the thing, and so on. So all this is generic in functionality. So we built this. And then we offer this to a number of different customers, and they built cool applications, and all of them are looking different. Some sends shitloads of data, some have massive amounts of users on top of the data and then very few things. Some have many things, and you send super little data, very infrequent, and some are not interested in the data. They just feed the data through the platform to their backend. And it's so many different use cases here and some actually using the thing as a gateway to controlling. So they want like a backdoor back to the connecting to the IP address of the thing, where they have a web browser server, web server. So they can, in the web browser, enter the IP of the thing and control it through a web GUI. And you can see that there's a multiple spectra here, of a very long spectra of different solutions. So that's just to set the stage.
So the stage of IoT is that there is so many variations of IoT. Becomes stupid as one because it's use cases depending on their processes and all that.
Yeah. So for instance, one classical use case is electricity meters, water meters, and so on. They only need to. I mean, if the traditional use case that came up like 10, 15 years ago is that they wanted to fight revenue leakage in terms of you can only bill what you measure legally. Okay, so if we improve the way we measure by connecting the meter with a SIM card, we can secure every single measurement every single second, but then it costs a lot. So they made a kind of a calculation, how frequent, every 15 minutes we can send a value. And if we miss 15 minutes, we can lose one and it's okay. But if we lose more, it starts to be costly for us. Okay. So then it's just a small device sending on a regular interval, something like that. And then you can involve this and say, why I'm sending every 15 minutes. Maybe I can risk to collect every 15 minutes or something, but I store it locally and send once a day. And then I can send it in synchronously during nighttime and do all the batch processing and construct the data to produce the invoices in the end of the month or something. So that is a very dumb meter in a way. It just produces. But if you then want later on in use case 2 or 3 that we're looking into, maybe now, then they want to use the electric meters in the housing as sensors of distribution load in the network to predict in real time what the distribution load should be in the next couple of seconds or minutes or something like that. But then the device that sends the data now has completely different hardware requirements and connectivity issues. So here is what happens in IoT. Your first use case, you can go with a very cheap and simple solution. But eventually you evolve into more use cases that are more advanced. And if you are fixed with the hardware, so electricity meters are changed maybe every 10, 15 years. So now we are into the 3rd generation. They are replacing this in Stockholm right now. I know mine will be replaced quite soon. And then the new one is more, of course, more improved. So that's one thing that is very complicated. So how long do you think that your IT use case will be live and relevant on the market? And that can drive you, guide you in terms of designing hardware, what kind of data use case you want, and how to collect the data and so on. But if you want to be long-lived, I mean, Scania, Scania and Volvo, they have a very different problem, or a similar problem in one way. But they need maybe 3 years ahead of launch of a new truck. They need to set the onboard hardware specs. Okay, the computer, the modem, which radio standards they're going to 2G, 3G, 4G, 5G, they're going to support. 3G, 3 years before launch, because all the other systems must be now developed around those very fundamental decisions. And then when it's launched after 3 years, it's going to be on market for 15 years. So now you are stuck with hardware for 18 years, more or less. That is a challenge in itself. So there you need to sort of, how can you design your IoT solution and evolve it over time with such constraints? It's very, very hard. So what also happens in this business is there are a lot of technology shifts in terms of connectivity. So you think that 2G is not around anymore, but it's super important for IoT because it's super energy efficient. You don't need to have that. It's not very expensive to maintain because you have very few base stations. You have long coverage. Yeah. So if you look at 3G, you need very dense cells to cover an area and so on. So it's still there. A lot of use cases. And there is a problem now because operators around the world don't see money in maintaining the 2G networks. They want to free up the frequency space in there for 5G and all this. Okay, so they need to take something down. And some countries actually are taking down 3G before 2G because they have 4G and they have 2G and 3G, but 3G and 4G is so similar.
Interesting.
So what happens then is that some countries actually tear down 3G because they already had natural coverage of 4G and
so 4G is close, but 2G has a different use case because it has a different dynamics.
But there are two new connectivity technologies will come out, or they are already on the market, but roaming-wise, they are really not super mature. But one is LTE Cat Emmet, so it's a version of LTE. It's like 4.5. And then we have narrowband IoT. Both of these is similar to the 2G concept, but even more effective in terms of...
So the modern version of the 2G problems.
So when you go to 5G or this next generation, there's like two completely different use cases in the spectrum of IoT. One is this self-driving car there, or the medical AI connected machine that's going to diagnose it or like keep a patient alive. It's reliable connectivity with super high, low latency bandwidth. Okay. That's 5G also. But 5G and these new technologies are also a very, very low power consuming, sleep mode aware technology to save battery of things that doesn't have power supply.
Yeah, but this is a really important distinction that people need to understand about 5G. So 5G is when you're really now going into a topic where 5G is actually several different types of 5G. That's what you're saying now. So 4G was LTE, 4G, 2G. Yeah. Now we're talking about you need to really know your use case now to buy 5G.
Yeah. So that's true. And this LTE Cat-M and NB-IoT, which are two similar technology to 2G, they are actually 5G compatible, but they are not really part of the future standard, but they will work in this. So that's super nice. So yeah, that's one of the things. And
I see a real problem coming up now, because when we move into 5G, and you basically need to really know which type of 5G is suiting your use case. You really need to be on top of the fundamental business case, the AI case, the use case application, and the way I understand the IoT, the networking industry to work is like, well, the big data guys, they're on the central part, and here we have some other guys, in overalls that goes out and do the hardware setup of the sensors, and the guys who is on the technically setting it up, they are not really knowledgeable on the use case. Am I right?
Yeah, it's a super hard problem. But if there are a lot of data experts out there and you're thinking about helping anyone in IoT, this is what you can do. You would serve so much help if you think about this from a data perspective or AI perspective. So what is required for you to deliver value out of the data from the IoT machines? And then it starts to open up lots of interesting questions. So first of all, where will the data be stored? Second, where will you train or refine your data and train your models? When you train your model, where do you deploy them? Okay, and where can you scale on, and which can you compromise on?
Yeah, so we are really now taking the hardcore stuff we're talking about, building a big data platform. And now understanding, well, the guys who were out in the woods who's setting up the hardware, whatever, the strategic choice is happening the whole way now.
Yes.
The data problem, the data processing problem, AI processing problem is the whole way now.
Yeah. So it's and then all the things around latency, and the when you can get the data to make a decision. So it is coming into play. And if you think about a very modern or traditional approach today is to have the devices quite lightweighted. They communicate data up to the cloud. And in the cloud, you can build your platform, control logic. You can store your data there most infinitely, and you can train your models. You can deploy your models there. What you need to send is the observation of the status of the thing up to the cloud, run it through a rule engine that points to a model, get the prediction, and evaluate the decision, and send the instructions back to the device. So that's a very effective way, but you do have the round trip to the cloud.
It's a latency problem.
Yeah, but
most of these... Not only that, what do you think about edge computing in general? I mean, it has a lot of impact in terms of, for one, latency, of course, but also privacy, right?
How you mean?
If you have like a mobile phone and you're doing something on a mobile phone that you don't perhaps want to share with some kind of server on the cloud, then you can do that on the edge in the mobile phone, and you don't have to share the data. Hence, the privacy is preserved.
Yeah, and I haven't really thought about it like that. But of course, this is the problem, though. If you're going to build a model of something a device collects locally, the amount of data is so small. Yeah. I mean, it's like...
But then you have federated learning.
Yeah, but how do you do that? Because then you need to send the data or like...
just aggregates of it.
Yeah,
still,
yeah. So the thing is that...
You don't send the data, though. You just send the model that you update, though.
Yeah, okay. So then That may be one work. I haven't looked into this.
We're
That's
getting
interesting.
edge intelligence. I think goes together with federated machine learning at some point.
Yeah, but what I rather argue is the other way around. That I haven't looked into this detail. So, but what I rather recommend, there's a lot of good design patterns for this and technologies and frameworks, and that is that you actually send all the data to the cloud again, and you train the models in the cloud, but you push the model down in a lightweight version and package it in like a binary form down to the device so it can operate locally. But then you can train on all the devices data from all the different, if you predict accidents or something like that, then you can see you have accidents for all devices and collect that if they will buy like cars or something. Not just that car, because if it crashes, it dies. They cannot learn from that. I know that's maybe one way. So that's one way. And this tiny ML is one way to do it. AWS actually have a full framework for this, where you can train them in the SageMaker model in almost most of these TensorFlow stuff and that, and you can push them down the SageMaker prediction engine down to this case is pretty massive thing like a
Pandora's box here,
Raspberry Pi, which is quite big, but yeah, but you can
okay.
actually put in. I think they actually work down to microprocessor like ARM-based stuff.
But do we have any key takeaways on
I think we just have. It's already 10 to 7 here, so I'd like to move a bit more into more philosophical questions and perhaps just staying.
Before, let's close the topic. What the industry topic now, we are seeing a complexity, as I see it, in terms of understanding and delivering on this value chain. Yeah. And I think that is something that we need to figure out as an industry, as consultant industry, and what the offering of connection is going to be and all that. Yes. I think that is different.
But one takeaway here is if you design your solution based on your data objective or data agenda, it will help you a lot in the decision making along this road.
But this is the point, right? In order to make the right architectural and buying decisions, you need to be data and AI ready and literate. The problem is that the decision makers who knows the data is not part of the IoT decision makers, because this is the networks guys. So it's a flip on who needs to be involved, because I fully agree with you 100%, but they are not the guys that usually bought the sensor in the past.
Yeah.
That's my problem. That's the thing we need to figure out. I think that's a good wrap up. Now,
well, I was actually going to continue the 5G thing, but perhaps I shouldn't. But still, okay. We always have to speak about Elon Musk on this show, for some reason, and I guess in your case it's extra.
You're paid.
Relevant.
It's a commercial.
But I think in your case with Telenor, it's extra relevant as well. And I just heard actually recent days that they're going to launch like a Tesla phone as well, with a connection to Starlink. Their low Earth orbit satellites that they have, and that's going to potentially provide a complement or an alternative to cellular networks like Telenor, right?
Yes.
What's your thinking about 5G versus Starlink? Do you have any general thoughts about that?
Of course. There is one very, very...
He woke up now. That's a good one.
Yes. So there's one very... Let's see. What did you say?
5G Telenor versus Starlink.
Okay. So there's one fundamental thing that the telecom industry can bring to the table that private initiative doesn't do. Okay, it's a standard that works everywhere. So you can go with your mobile phones now to everywhere in the world. This will not work, maybe, unless Elon Musk makes this 3GPP standard according to the telecom standard, which requires him to follow all these different protocols and so on. If he makes that, then it's really that's a really threat or threat. It's really a merge of different technologies, but otherwise it will be proprietary technology that will be limited. And we have number of these. We have Sigfox, so that's a technology that is similar to the NB-IoT and LTE and CatNet. It's very energy efficient. But it's proprietary, so you can build Sigfox, buy build Sigfox devices, and you can more or less use them to a network. But if they decide something, there's not a standard. You can't use anything else. It's their standard. They have licensed the products more or less. So that's one. And the other way is this LoRa stuff, which is a completely open standard. It's like Wild West. It is not regulated. So one thing that's really important with the 3GPP standard and the frequency that the telecoms buy is that there's a guarantee of your frequency uniqueness. There's nobody else that can use that because you buy a license in the air. You can occupy this. You have bought the license to occupy the air. And this is then giving you the quality assurance to build critical use cases on. And if you just you go with some other technology or try to go not according to the standard, go to PTS and buy a license, then you need to use open frequencies or you violate law.
Yeah. No, but I think Elon Musk as well said that, the Starlink satellite connection is not competitor to fiber nor a competitor to 5G or cellular networks. But
Yes.
who knows? And especially, I was very surprised to see that he's actually launching their own phone, which has a direct connection to Starlink, and that works, throughout the
was
world.
expected. Why would you buy satellites with the internet and do a mobile?
Probably
the best
But
mobile in the world, right?
He just wanted his own mobile.
Yeah. And looking at what he has accomplished, I wouldn't be surprised if he's successful in this.
Oh.
So I'm not surprised about the idea. I know Facebook had the same idea, like to run balloons, don't they?
Yeah,
something like
that.
that. Yeah,
yes,
yeah.
But that failed a bit. But
Yeah. So the problem is, I don't know. Can you have these above in foreign soil? I mean, would Russia allow you to have satellites over them, or would they claim that you're in their space somewhere and shoot them down? I don't know. It's a bit tricky.
Do you see them as a serious competitor or not?
Yeah, I would say whatever Elon Musk and his companies are doing, I would say that that's serious competitive. They would get it wrong a few times, but they will get it right in the end.
Yeah, I think it will be a great compliment to have both 5G, have fiber, but also have satellite.
In that, whatever they are doing, I think there is high potential to coexist.
Yes. Yes.
Can we already now understand some fundamental difference in types of use cases for Starlink versus 5G? Or they are some overlapping, but are there some fundamental, simple examples?
So the laws of physics are of course limiting a satellite thing. I mean, if you try to send data over satellite, you can't stream Netflix that easily. It's
They claim to be
but
really low latency.
Yes, but what the why you get high bandwidth in 5G is that you can zoom in. So if I am a base station, I can send to both of you here with a focused antenna, sending it exactly to you and not all over the place. Okay, so that's how you get really high speed. With the satellite, how do you do that when you're even longer away?
You have 30,000 of them though, but yeah.
Yeah, and still, if you look at the NB-IoT case, that's actually super good underground and indoors. Okay, so how would a satellite, even you lose the GPS coordinates if you go into a tunnel? Okay,
yeah.
So that's
exactly.
that's
a really
probably
good point. It is. I think it will be a clear compliment, but yeah, interesting to see.
Yeah. We are running out of time, but I have. Do we want to go philosophical
at this one, or do you want to take some questions?
I mean, I really wanted, because one of the key pets that Anders has is to talk about culture in one point, and like the importance of data culture, and another point.
Which Anders are you speaking about?
Are we that different?
Exactly.
No, but Anders Bresell.
Okay.
And then also, I think you made some quite interesting insights in understanding what works and what doesn't work with your customers. So I think those two are really nice topics. And then we can have philosophical topics, and then we need to go for 1:15.
Okay.
What do you prefer? Do you want a philosophical topic?
But
or do you want
try to explore a little bit about culture. I don't think I have good answers, but I reflect over it a lot. So.
I was more into the reflection. I mean, this is philosophical maybe as well. Yeah. Reflecting on culture and data.
Yeah. So here is just a disclaimer. I don't try to enforce a culture of a data-drivenness or like AI readiness. I don't do that deliberately. I rather choose a place where this is more natural or easy to establish. They need to be data savvy. They need to be hungry for insights. They cannot be technology scared for technology and so on. They need to be in this mental mode already. Then I can be so much more effective. Otherwise, I need to go and hang on my management jacket, consultancy management jacket, and do PowerPoint presentations and convert. I've done that too, but it takes so long time.
And so much energy.
So maybe I have
wasted
cheated through my career.
to work with the data savvy.
Yeah. That's one way. I mean, what would you prefer?
No, but bottom line is that it means that if the data culture is not there, it's going to be a really, really hard slug.
Yes. On the other hand, I've seen cultural changes. So I remember, I don't know if I can talk about this, but I was at AstraZeneca multiple years, and we had problems with leadership because we had super passionate researchers that made a huge effort driving a research forward and driving the drug development and so on. But the decision makers said, yeah, but it's not working. So you need to go back and do better. Okay, they said this all the time, to the point that the researchers went 7 extra miles, did multiple more studies, prepared their way much more, and went to the same leadership meeting to be thrown again in front of the train and say, you didn't do good enough. It didn't work. So that was really bad. So you almost got afraid of presenting any results. This is my interpretation, so I don't say that this is the case it actually was. But then what happened was they brought in some fantastic management, super expensive, with lots of high hourly rates, and they transformed the leadership. They transformed every single layer over 2 years, reprogrammed them. And the last 6 months, we at the floor got this transformation of attitude. And one of the few things that they changed was that we stopped being innovative, because we knew that every single idea will be claimed to not work if I just fail once. And that was so hurtful. So we had to change this.
The whole attitude had to change. The whole mindset had to change.
Exactly. And they did the most effective thing I observed was that the leadership recognized how wrong they were. They thought they were right. They believed in the company. They just saw that those that didn't produce results didn't work as hard as they do.
But they did, of course.
They did, of course. Why would they? They are equally proud and maybe even more experts in what they're doing. So that was wrong. So that was a recognition. I did wrong. I should have been more here. They had color types and so on, of course. But that was amazing to see that transition. They did also something else that I found is fantastic. And that's the way you measure the way you get behavior. That's an old saying. But if you've seen that in real life, it's
metric.
Yeah. So we measured, the drug development life cycle takes 8 to 12 years or 15 years, and you divide it in different stages. So you get bonus every time you pass a stage. So every team now is responsible for pushing the drug candidate to the next stage. And there are like 10 stages. So everyone there were so many December awards, on new drug to the next stage, because that was bonus. So everyone saw that it was great. Maybe it was deliberately, but I think it was unconscious. What they changed was that nobody got any bonus until we prove it actually works in patient. So that could have been a bonus that when you need to wait for 6 years. But what it turned out is these teams now had to start talk to each other to see why the things that I sent to you didn't work. Yeah, nothing worked. So what did you try? What did you do to say that it actually worked? And they started to exchange ideas, and they changed information and the total culture of don't go and question my decision, to what can we do to improve, to go forward and win together. That was magic.
Awesome, I think.
That's an awesome learning.
And it's also connected to, I think, the failing fast idea. And just to once again quote Daniel Ek, the founder of Spotify, that, you know, at the critical point in the history of Spotify said, you know, we are going to be the company that fails the fastest. And that sounds really weird. But if you truly understand what he means,
yes,
it is truly about, you know, capturing the culture of allowing people to fail. And thereby allowing people to be innovative and finding the 1 out of the 10 that actually do.
People need also to know when to stop trying.
Yes, you shouldn't do the incremental thing, you know, continue for a year on something that doesn't work. You have to fail fast.
Yes.
Right? Should we do one philosophical and then end on some more, one negative and then one positive philosophical thing, perhaps?
Go for it.
So we don't end up on some negative part, but starting with a negative at least. And we've spoken about the AI divide, you know, so many times. I'd just like to have your thoughts about this, because you also have an interesting, you know, background, both being an academic and in the industry as well. You can also see how the tech giants are really accelerating in a pace that is extreme. And you can see how the brain drain is happening from the universities to the tech giants, at least in US and in China. Perhaps not as much as in Sweden so far. What would you say in general? Are you positive that the AI divide will not accelerate more? Or do you think the industry and academia will actually start to catch up a bit? Or what's your general thought?
I think, honestly, I'm a very positive person. I think that those that are not there, ready today, they will evolve, and they will be in the game of AI. Most of them, I think. And what I'm also thinking is that it's not totally the data agenda and the AI agenda that will drive success. It's also the what do you call it? The idea or the business concept. I mean, if you're proud of what you're doing, I mean, you don't digitalize or put AI on cleaning apartments. But if you can build a robot that does it. But a person that is extremely proud of their work will clean extremely good and will beat an AI every time. Maybe not in speed, but almost, okay? So, I mean, proudness in whatever you do, there's room for this in every business, because the passion about what you're delivering is extremely important. So that, I think, there's room for that. But if you don't have passion and you don't do AI, what do you compete on? You can compete. If you don't do AI, you can compete on price, you can compete on quality, you can compete on volume or scalability, I don't know. So, but you can compete on passion. That I think. Okay. And that doesn't need to be scalable, but it actually works.
If we go a bit more positive, perhaps, and if you are a bit more futuristic as well, and think like 10 years ahead, what do you think the future of telecom business will look like in 2030? Do you have any thoughts about, you know?
It's actually very close in time. So that is not...
Close in time?
Yes. Things move extremely slow, in my mind.
Okay. Interesting.
I mean, if you evolve 6 generations in a big data platform in 6 years, telco standards are replaced every, 8-10 years. It's
So we're still in 5G in 10 years? 2030 5G still?
Yes, I think so. 6G maybe is coming out, but I think 5G will still exist. I mean, we are looking 2025 when the last use case of 5G will be rolled out. This is the different parts of 5G promises, and the first one is out now. It has high data for new phones. Okay,
there's a journey to take it up, to change.
What I've seen lately, and I'm not fully convinced that the telcos are they need to convert to a software company. So I've seen successful products, maybe from Telenor, like the streaming service that is fantastic in terms of they developed it in 6 months as a hackathon, and it became a product. And it's equally good as Viaplay that has been out there for many, many years. It's better than C More and so on, and TV4 that has been there many, many years. I think there is a conversion to software and services beyond telco. We've seen this in Asia in our companies there, and they are driving banking, microloan, and so on. But here there is a matured business, so you can't actually compete on existing sectors.
But do you think it will go to that? I mean, if you look at Amazon, they go growing, like, including everything in their service and having the Prime membership. And in China, of course, you have the kind of big Alibaba that provides everything in a single service, including potentially telecom services. So do you think that will happen in Sweden as well?
Let me say what I'm going to, a more exciting thing though. I have a very hard time to predict the consumer telco business. Yeah. But from managed global IoT connectivity, how would that, because that's based on roaming business. So here's what I think that probably will, maybe not even in 2030, but it will be close. I think there will be really good standards that is proposed at that time. And that is using blockchain from your SIM card to charge and negotiate on prices on roaming live, and you are paying through a virtual currency. So there is not this agreement where managers or negotiators sit at a table and produce a PDF document and sign it. These are the prices we're going to do for the next 1 year. This will be live, but depending on demand and capacity, and you can get your data through, or your capacity through, from your device or from your machine or even from your commercial phone or like end consumer phone. You can buy capacity based on a blockchain concept where you pay and smart contracts. Yes. So this is what I will think that the whole, and if we remove this roaming ban in the same country, this is what will happen. It will be an open market for connectivity.
So you actually open one of my hate topics, but I'll still have to go there a bit, and I try to do that the positive way. But so blockchain in one way can be seen as a technology to remove the middleman in some way. Yeah. For example, it can remove the middleman of banks. Exactly. Could also remove the middleman of like record labels when it comes to music. Do you think it can remove the need for telcos as well?
Yes, absolutely. I think so.
Interesting.
But there is something that you can still do as a telco. You can build networks. Okay. So as long as you build networks, you're part of and you can offer it through this blockchain solution now. Yeah. And then you have more antennas, you have more coverage, better coverage than others. That means that you will get more of the customers.
But is the fundamental marketplace looks different?
Yes. It's not, the problem here is, of course, that what stops it fundamentally today to get beyond the standard telcos is this licensing thing around the frequency bands. Mm-hmm. But if that still remains, it will be a market for those that have licenses. Mm-hmm. And then still blockchain transactions here can still be removed, the middleman going up and saying that I, as an end consumer, need to accept the price that I have here. No, I can check with the other one and I can say, yeah, but the lowest price I've been offered is this one. Do you want to match it?
Right.
Okay. So then you transfer the power down to the consumer and say, do you want more bandwidth? Can you wait? And you can send, is an electricity meter now? You can send when it's cheapest. It's when we charge electric cars now. We charge it when it's cheapest. We don't do it in its most expensive. I think data and connectivity can move into the exact same spectra.
Yeah, I mean, I agree. That's an interesting
It's an interesting view.
Sure.
And then you say blockchain as an example, but ultimately this is about solving smart contracts or machine-to-machine contracts.
There are many
Potentially it could be blockchain, but it could also technology-wise, maybe we have another way of doing it. But what you're highlighting is machine-to-machine contracts in real time.
Yes.
Yeah, I think that is, I mean, like from the energy business, this is happening more and more with blockchain, by the way. We have the PPAs, the power purchasing agreements that used to be done with a lot of suits to do, I want to buy, IKEA wants to buy green energy directly from the specific wind farm in order to have certified green energy. And this can now be done with smart contracts, of course, and with blockchain. But I'm not sure that is the way it's going to take off, but it's happening now. And unfortunately, not so much in Sweden as it is in other parts of the world, which is some of these things that we're talking about, by the way, is happening in other parts of the world already, I guess. I think we are coming to an end, 1:15, and 2 last simple questions. What is next on your agenda in your life or at work? What are the things you're looking forward to in the next couple of months? Or
near term, there are a few projects, a technology solution that we support that I hope will transform a little bit of the market. Will not be fundamentally will be on the news, but those in the business hopefully will have wow. Okay.
So you have some cool
they
stuff.
were first. They are shaping the market.
Can you give us a scoop?
I always wanted to be that person. No, cannot. But that's
Give another beer.
Give another beer.
Yes,
We need a scoop.
no, it's but it will be soon launched probably.
Oh, exciting!
So it's not a matter of long time. I think so. It has been great fun to be part of that journey and seeing it realized now and building the technology to enable that. So
that's something you've been working on for a while?
Yeah.
As a launch?
It's not so much data and AI and so on, but it's
interesting.
In the sense that in order to enable that functionality, the real-time streams and the data we collect is fundamental in enabling that.
Yeah.
It's not per se, it's rather...
But in the end, we need to start building smarter and better data pipelines, data products in order to unlock new use cases on top.
Yeah.
Okay, that's interesting.
Yes, and secondly, I'm pretty new in the situation where I actually only should focus on data. I actually had for the past 5 years or something been head of software engineering or development also. So I had my software engineering team. Actually, most of my team members have been engineers and software architects. And I will now formally since 1st of June, but actually now from 1st of November, I will leave over my dual role now to another person. Leonard, you'll be doing great on this. But then I can actually start focus because the problem now, I want to think really strategically. I want to shape our company. I want to shape the business. I want to shape the market by being better and smarter on how you can use data. And for that, I need time to articulate and position my ideas in a way that is executable and present that with assumptions. Yeah. And get the funding and the team to do it.
So you're going to have an exciting 2022, put your mind in the full data space.
Yes, but there will be shitloads of stuff coming from the side. Being center of everything that happens, having all the data that ever passes through the company, it's quite easy to be dragged into every single product because I will know everything about every product. It's a problem and it occurs, but it's also a fantastic position.
Opportunity.
Yes,
let's see it as an opportunity. Yes. Wow, cool. And then the last question: do you have any recommendations for guests that you would like to listen to or see on this vlog? Pod.
Yes.
Stream.
Pod stream. Yes. That was a good question. I know there are a number of anyone. You probably have people from Spotify, but they are extremely good at taking insights into actions and driving this momentum of just how to improve a search algorithm. How many letters do you need to type according to your...
We're actually going to have a Spotify search person coming soon.
Yes, exactly. Because that has been one of my mind-boggling things, actually, in all the conferences I attended, where I understood how quickly you could improve and train your models and try it out in use A/B testing. So it was magically. That was an eye-opener. It was many years ago. But that's good. Then you're already on it.
We're on that.
Yes.
And you know, I'm a Spotify person as well.
Yes. And otherwise, anyone around that knows more about data engineering and building platforms, I think it's exciting. But I know this much that I told you now. But I have experts underneath me that would be equally or much better than describing this than I am. But yeah, so that might be something. But yeah.
I loved all the technical details you were able to go into. So that was really fun to me, and I hope some people that are like me enjoyed that as much as I did. So.
Yes.
Yeah, actually, shout out to Rasmus, who was very active on the chat today.
Yeah.
So yeah,
Awesome.
Cool. All right. With that, I think it's time to let go of the live stream, and then we have an AI afterward.
Wow.
Continuing.
That's awesome.
And then we're going to hear about the upcoming plans.
Yes.
Now
Then they're going to serve me more beer and I'm going to drop their secrets.
Thank you very much, Anders.
Thank you very much. This was magic. Thank you.
Cool. Thank you.